Yeah, so today I will introduce very briefly China's Tianwen-1 mission to the Mars. And this mission launched last year in like June and will already arrive the Mars and will landed on the Mars in this year in May or June, this year. So my topic today is Tianwen-1 mission to Mars. And I'm from China University of Geosciences. And at last of this presentation, Jim had some very nice ideas of the landing site. So he will take my slides to present something about the landing site in Utopia region. So let's go. So this is a very brief introduction to Chinese Mars exploration program. Some people say Tianwen-1 mission is China's first Mars exploration mission. That is not correct. Actually, Tianwen-1 mission is China's second Mars exploration mission, and the first China's Mars exploration mission is Yinghuo-1 mission, and this mission launched with Russia's Phobos grant, which is Phobos sample return mission. But this mission has some problems when launched and never leave Earth's orbit in 2011. So very sadly, but right now we have another mission run by China, by CINSA itself, which is the Tianwen-1 mission. And this mission is composed of three components: one orbiter, one lander, and one rover. Three components together. And in the future, like this is nearly confirmed in 2028, there will be a mass sample return mission applied by CINSA. And the Tianwen-1 mission, is a little bit different from other China's planetary exploration mission because a Tianwen-1 mission has lots of international partners, especially from ESA and from France. And from ESA, we have different levels of cooperations. And from France, we have cooperations in produce this laser introduced breakdown spectroscopic, which is LIBS instrument. And Argentina have cooperation with tracking station, and Austria with cooperation with this payload on the orbiter magnetometer. So lots of cooperations. Then let's move to the mission profile of Tianwen-1. Tianwen-1 launched in Wenchang Space Launch Center. If some people was not familiar with China's space centers, it is in the south of China in a very huge island, and it was launched in July 23rd, 2020, and after launch it takes like around over 200 days from transfer from the Earth to the Mars, and there is some very interesting things when Tianwen-1 went to the Mars. The first one is Tianwen-1 actually takes some selfies by dropping very tiny cameras, and when the camera was dropped from Tianwen-1, it was rotated, and when rotated, this small camera take lots of pictures, like one picture 1 second, and this is one of them. And the very small camera, which was dropped by Tianwen-1 using Wi-Fi technique to transfer these images to Tianwen-1, and Tianwen-1 transfer the images to the Earth. And this two images was travel very close to the Mars, which is a very recently in February 5. And these two images are taken by Tianwen-1, and the first image taken by Tianwen-1. And this was taken not using the scientific cameras, but using some monitoring cameras. So the color here and the resolution here looks not very good. And in February 10th, Tianwen-1 entered the Mars orbit. Here is a very tremendous image, which was taken when Tianwen-1 entered the Mars orbit. You will feel the trembling of Tianwen-1 mission. And after this maneuver, Tianwen-1 successfully entered the Mars orbit. After entering the Mars orbit, Tianwen-1 did some orbital corrections. The first one is from equatorial elliptical orbit to a polar elliptic orbit, then to a parking orbit. Right now, Tianwen-1 was is in the parking orbit with a perimeter of over 200 kilometers. And in this stage, Tianwen-1 started to do some scientific investigations, and especially Tianwen-1 was on the parking orbit to do some investigations of the landing site. And later this year, in May or June, after like 3 months of landing site investigations, Tianwen-1 will landed on the Mars. So this is the components of the Tianwen-1 mission. As I mentioned earlier, Tianwen-1 was composed of 3 components: 1 orbiter, 1 lander, and 1 rover. So this is a 3-in-1 mission and makes this spacecraft very heavy, over 2 metric tons. It is a very heavy mission. And with these 3 components, China will can have the ability to not only orbit the Mars, but also land on the Mars and to do some surface operations. Let's say the payloads. So let's say the scientific objects of the Tianwen-1 mission. There are different. There are 5 major scientific objects of the Tianwen-1 mission, like do some geological topography, sculpture investigations, and composition investigations. Composition and ionosphere and physical fields investigations. So, and this are, because of this scientific objects, there are different tasks that will be conducted by the rover or the orbiter. O means orbiter, R means rover. So different objects will be achieved by different observations on board using the orbiter or the rover. So, but if you check the scientific objects or some specific things I listed here, you will find that Tianwen-1 mission is an excellent geologist, is an excellent geophysics, but it's not a geobiologist or astrobiologist. That means Tianwen-1 is not designed to study the potential life on the Mars. But with all this, with all these things to do, Tianwen-1 will become very important to study geology and geophysics of the Mars, because to fulfill this scientific objects, Tianwen-1 was installed different payloads. There are like 7 scientific payloads on board the orbiter, including middle resolution camera, high resolution camera, scientific investigation radar, mineralogical spectrometer, magnetometer, ion and a neutron particle analyzer, and energetic particles analyzer. You will find that in some images, the payload name is a little bit different from other maybe articles or images. This is mainly a translation problem. So if you find they are not the same, actually, they are the same payloads, but translated into different English names. So there are 7 scientific payloads on board the orbiter, and to do this specific observations and to fulfill this tasks is. And I want to highlight 2 of them later, which one is the first one is the radar, another one is mineralogical spectrometer. And there are also 6 scientific payloads on board the rover, including navigation terrain camera, multispectral camera, rover penetrating radar, compositional detector, magnetometer, and climate station. And these 6 cameras will be used to do these different tasks. And for the name of the rover, very coincidentally, there was a popular vote for the rover, for the name of the rover, and in the early stage, there are like around 20 candidate names for this rover, and just yesterday, the popular voting for the name of the rover was announced, and these three have the three highest polls. So these three are now 3 of the 20 most candidates for the name of the rover. Let's take a look. The first one is Zhurong, means the god of fire, and Naja from Chinese mythological figure, and Hongyi means a broad and strong mind in Chinese. Some people say that this is just the meaning of perseverance. So we really need to perseverance and very hard mind to go to the Mars. And for the scientific payloads on board the rover, I want to also highlight 2 of them. The first one is the penetrator radar. Another one is the surface composition detector. This is the 2 major payloads that will fulfill the geological and geological investigations. First, let's say one highlighted payloads, which is the Mars Orbiter Scientific Investigation Radar. These are some parameters of this radar, like with this is a high resolution radar, and with a penetrating depth of over 100 meters if the target was soil, and over 1,000 meters if the target penetrating depth with the target is water ice. And the altitude accuracy is 10 meters, and the resolution, spatial resolution, didn't see that. And compared with, actually there are another 2 radar already orbiting the Mars. The first one is Mars SIS on board Mars Express, and another one is SHAD on board MRO. And according to my friend, if you just see the numbers here, the Mars Orbiter Subsurface Investigation Radar on board Tianwen-1 will be a little better than SHAD. And the scientific important thing of the investigation radar is there are lots of subsurface sculptures on Mars, especially the Utopia Planetonia region where Tianwen-1 mission will land. And as you know, Tianwen-1 mission when it planned to land, the landing region is very close. It is a close point for Tianwen-1 mission in the Mars orbit, so it will get a very high resolution in where it will land. So Tianwen-1 mission, the scientific investigation radar can tell us a lot the subsurface sculptures in the Utopia Elysium region. And this data can be compared with the SHAD data of this region to investigate the subsurface sculptures and maybe some water ice interactions in this region. Another payloads I want to highlight is the penetrating radar. Penetrating radar is was on board China's lunar missions and this Mars missions every time. That is because the penetrating radar, I think it has some advantages. The first one is has much more high resolution than if we other geophysical investigations such as seismic investigations or observations. So Tianwen-1 mission has a penetrating radar on board with signal frequencies in these values, and it can detect. It has 2 detection modes. The first, the channel 1 can detect ice in 100 meters, soil in 10 meters, and the channel 2 can detect ice in 10 meters and soil in 3 meters. The 2 detection channels has different advantages. Although the channel 1 can detect a much more deeper, but the resolution is lower. The channel 2, the detection depth is lower, but the resolution is higher. And actually, we already prepare a very long time for this penetrating radar. Every year, we will go to a Mars analog site in northwest China to do some ground penetrating radar investigations of yardans or other sedimentary rock of that mass analog site. And these are a recent work by our group of the Pangean radar data study of that mass analog site of yardans or other sedimentary rock. And interestingly, the NASA's Perseverance rover also has a Pangean radar, which is named RIMFAX, and the RIMFAX has this instrument parameters, and it looks the RIMFAX has maybe median. The resolution is very similar to the Pangean radar on board Tianwen-1, because as you know, maybe the Tianwen-1 landing site will be very close to the Perseverance landing site, which was already known. It's very nice to compare the different data gathered by these two Pangean radar. It can let us know much better the subsurface sculptures of the Mars, especially sedimentary laying. The third one is mass meteorological spectrometer. The mass meteorological spectrometer on board is on board the orbiter with a spectral resolution between 0.4 to 3.5 microns, with a spectral resolution between 3 to 10, I think, nanometers, and it is the detection mode of the mass meteorological spectrometer has 8 detection modes, so it's very complex. Its detection mode is very complex. I checked this paper and I found that maybe the mass meteorological spectrometer need to cool down in every observation, so it will approach the Mars surface to like over to 265 kilometers to the Mars surface and do 20 meters observations, and I need to leave the Mars to cool down. So so maybe this is related to the approach or observe the different operation modes related to how to approach and do the observations. And there is another mass spectrometer already on Mars, which is CRISM. And CRISM has a resolution in 0.5, 0.4 to 3.6 microns, and has a very high resolution. The resolution can reach, I think, hundreds of meters. So I have compared the parameters here and the parameters in CRISM. I think the CRISM is better than mass meteorological spectrometer, at least for globally. But as you know, the Tianwen-1 mission's elliptical orbit, so in initial observation stages, it may be very close to the Tianwen-1 landing site, the potential Tianwen-1 landing sites. So it maybe get much high resolution data of the Utopia region where Tianwen-1 will land, but maybe globally it will be worse than the CRISM. And the last payload I want to highlight is the mass surface composition detector. This payload was produced through the cooperations with CINSA and ESA and CNES. And actually, the CNES or the ESA group also developed the CAM camera on board the Curiosity rover, and they also developed the LIBS, the LIBS system for the EX Mars mission. So it's very nice to compare the payloads developed by the nearly same group and compare the different data. And the interesting thing here is the Tianwen-1 mission, the kind of calibration panel was provided by CNES, and it is the same as the calibration panel on board Curiosity rover. So it's very nice and interesting to compare them in different mass environments and in different locations. And another payloads, another components on board the mass surface composition detector is the spectrometer. This spectrometer has a very narrow observation range. So I don't think this spectrometer, the passive spectrometer, can tell us some information of the hydrolated mineral, because the spectral range will stop at 2.4 microns. But it's still the surface composition data can tell us lots of the mineralogical and composition information of the landing site. Then you may want to ask why Tianwen-1 will stay such a long time in the Mars orbit before it landed on the Mars. That is because this is the first time China run a mission to Mars orbit, and we need to prepare for land. And let's just take this video. So this is a Tianwen-1 orbiter. You will do surface investigations before it actually land on the Mars. And this is, I think, the candidate landing region in Utopia region. And with several maybe most favorite or favorite or most suitable landing regions. The Tianwen-1 mission will investigate the geology and the dust condition, especially the dust condition of this region, because the Tianwen-1 mission, the rover was not powered by nuclear batteries. So my last slides will be presented by G of the Tianwen-1 landing region.
Yeah, just a few comments here on the characteristics. What we show here is indeed the relationships of these different sites here. A really important thing is, of course, that the altitude dependence is critical to a safe landing, depending on how you go, of course. So most of these, except for Phoenix, have been in the near equatorial region. But beyond that, there's a really important focus on, of course, the scientific goals and objectives. And we know now that, for example, Curiosity is in Gale Crater, which is a closed basin lake. There's a valley network coming into it. It apparently has emptied water into it, but it hasn't filled it up to overflow. Perseverance will go to Jezero Crater, which is an open basin lake, which will in fact has landed on the floor, of course, of the lake that has two entry points, two deltas. The lake obviously filled up because, in fact, water flowed out the other end and went down into the Isidis Basin. So, in fact, that's an open basin lake. Both of these are the same relative age, generally late Noachian, early Hesperian. And most of these, of course, are really oriented towards trying to understand what's going on in terms of follow the water, what that might mean about life. Was Mars warm and wet early on? In fact, for how long and what way? And these are critical questions, again, for the origin and evolution of life. So Mars is, everybody knows, an excellent laboratory for the study of the conditions that might have led to the formation of life. So a critical point here is that Tianwen-1 indeed will be targeted into this area here. You notice the three more specific points that Yuqi pointed out, one about here in northeast Utopia, northeast Isidis, and then two here in Utopia Planitia. And again, the spacecraft, like the Viking Lander 1 and 2 spacecraft, the orbiters went into orbit and then waited a while collecting data to try to validate the landing site. So that's what we did on Viking. It was very exciting. We had landing site meetings virtually every day as more and more data came in. And that's what's going on here with the Tianwen-1 orbiter, as well as people gather data as it becomes further commissioned with all the experiments and analyses of the data is carried out in much more detail. Safety, dust, as Yuqi mentioned, and so on. So a critical point here is that these two craters, Curiosity's Gale Crater and Perseverance's Jezero, again, are open and closed basin lakes. They're up in the edge of the highlands, okay? And as most people know, the area of the northern lowlands is once thought to have housed, basically been the site of a huge body of water, an ocean, if you will. And this is one of the things that Tianwen-1 will be able to, in fact, test, is this area here typical of sediments or deposits, or maybe even organic material that might have been typical of an ocean in its early history. So Viking Lander 1 also landed in a similar type of area. Pathfinder did as well. And so we have materials that we can compare to what the Tianwen-1 site is likely to be like. And a critical point here is that the shoreline of this purported ocean is approximately outlined by the blue area here. And indeed, Utopia Planitia falls below that, and indeed is the site of potentially an ocean. So let's just go through the geological history. We have, in fact, the formation of the northern lowlands, which are thought to have derived from a huge impact, oblique impact in early Mars history, which essentially stripped off much of the northern crust and formed the northern lowlands. Subsequent to that, a very large impact formed Utopia Basin here. And then in the late Noachian, it's thought that there was an ocean that might have extended actually up to the edge of the green line here. This is the so-called Noachian Ocean. And then subsequent to that in the early Hesperian, late Noachian, early Hesperian, those could have been fed, that ocean could have been fed by these open and closed basin valley network lakes, etc. And subsequent to that, there was a phase of volcanism that essentially repaved the northern lowlands to depths of many hundreds of meters, actually. And that was the Hesperian Ridge Plains volcanism. And then following that, the outflow channels came out from the circumtharsis region in both directions here and also elsewhere. And it's thought that, in fact, that may be a second ocean that formed on top of the volcanic plains here in Utopia Planitia. Now, subsequent to that, of course, you have the Elysium area here, a huge volcanic area. This indeed formed deposits that extend out to the floor, in fact, well into the floor of Utopia Planitia. These look to be lahars, which are essentially magmatically and volcanic ash mobilized mixtures of sediment and glacial deposits, et cetera, that essentially flow out into the surrounding area here. So that's another candidate for material in the Utopia Planitia. And then, of course, you have the polar regions are not too far away from Utopia Planitia. It's about mid-latitudes, mid to upper latitudes. And one of the things that goes on there is because Mars, in fact, tilts as a orbit, it has orbital obliquity, undergoes major orbital obliquity changes. And we know that when that happens, ice is mobilized from the poles and deposited in latitude-dependent bands throughout, even down to tropical mountain glaciers here. So we anticipate and we see evidence for lots of activity associated with these glaciers here, including a more recent one that seems to come down to about 30 degrees north and south latitude. It might be a few meters or so thick. So this is really exciting because we have a lot of detailed geology in these areas here. It's going to be complex, but in fact, we have beautifully already landed there in Viking Lander 2. So we have from the northeastern part of Utopia Planitia already some idea of what the surface might look like. And this is one of the things that Yuqi is working on is the characteristics of that site relative to some of these other areas and the kinds of questions that raises for the Tianwen-1 mission. So very exciting times. We're going to learn a lot from this. We have a stratigraphy of major units here, and the impact craters as well as the surface exposures are certainly going to reveal a significant amount about the history, and it could be, in fact, the first landing a little deeper into what is thought to be maybe late Noachian and perhaps early late Hesperian oceans on the floor. So very exciting landing sites. It'll be very complementary to what's found on Perseverance and all the other landing sites. And then, of course, at the next opportunity coming up in 2022 here, European Space Agency will launch spacecraft to, in fact, land in this area here, which is also right on the margin of the Northern Lowlands Ocean interpreted deposits. So yeah, so very exciting. We're really looking forward to it and anxious to help out. I had the pleasure of giving a talk at the Tianwen-1 mission review in Zhuhai in China, and I guess that was the summer of 2018, and really interesting, a great detailed look at all the experiments that Yuqi described, it's an exciting mission, very complementary to everything else that's going on in Mars exploration. So, you know, fingers crossed. We're really anxious for the final selection of the sites and also landing and surface operations. So that's it for me. Thanks.